The Euclidean algorithm. The Euclidean algorithm is a procedure for computing the GCD of two positive integers. It works very well when it is difficult to find the prime factorization of one or both of the integers. It also provides a method for expressing the GCD as a linear combination of the two given integers. We'll use an example to illustrate how the Euclidean algorithm works. Okay, so let's use the Euclidean algorithm to find the GCD of 70 and 126. Step 1. We use the division algorithm to find the quotient and remainder when 126 is divided by 70. We have 126 is 70 times 1 plus 56. So the quotient is 1 and the remainder is 56. Note, always place the larger of the two positive integers to the left of the equal sign. Step 2. We now use the division algorithm with 70 and 56, the remainder, to write 70 equal to 56 times 1 plus 14. Step 3. We now use the division algorithm with 56 and 14 to write 56 equal to 14 times 4 plus 0. Step 4. Once we get a remainder of 0, the answer is the previous remainder. So the GCD of 70 and 126 is equal to 14. Okay, let's try an exercise. Use the Euclidean algorithm to find the GCD of 305 and 1040. Go ahead and pause the video and do this exercise yourself, and then resume the video to check your answer. Okay, so we have 1040 is equal to 305 times 3 plus 125. 305 is 125 times 2 plus 55. 125 is equal to 55 times 2 plus 15. 55 is equal to 15 times 3 plus 10. 15 is equal to 10 times 1 plus 5. And 10 is equal to 5 times 2 plus 0. So, since we got 0, we take the previous remainder of 5, and we see that the GCD of 305 and 1040 is equal to 5. We can work our way backwards through the Euclidean algorithm to express GCD of A and B as a linear combination of A and B. Let's do an example. We previously found that the GCD of 70 and 126 is equal to 14 by using the Euclidean algorithm as follows. 126 is equal to 70 times 1 plus 56. 70 is equal to 56 times 1 plus 14. 56 is equal to 14 times 4 plus 0. We start with the second to last. 70 equals 56 times 1 plus 14. We solve this equation for 14 to get 14 equals 70 minus 56 times 1. Working backwards, we next look at 126 equals 70 times 1 plus 56. We solve this equation for 56 to get 56 equals 126 minus 70 times 1. 14, as we said, could be written as 70 minus 56 times 1. We could then replace 56 by 126 minus 70 times 1. Distributing, we get 70 minus 126 times 1 plus 70 times 1, which is 70 times 2 minus 126 times 1, which we could rewrite as 2 times 70 minus 1 times 126. Right, so we see that the GCD of 70 and 126, which is 14, can be written as 2 times 70 minus 1 times 126. Right, so we've succeeded in writing 14, the GCD, as a linear combination of 70 and 126. Okay, another exercise. Use your solution to exercise 4.35 to express GCD of 305 and 1040 as a linear combination of 305 and 1040. Okay, go ahead and pause the video, try this yourself, and then resume the video to check your answer. Okay, I'll start by writing down the solution to exercise 4.35. I'm also going to color code it so it's easier to follow the steps. Okay, so we have 5 can be written as 15 minus 1 times 10, which is 15 minus 1 times 55 minus 15 times 3, right? Because we could replace the 10 by 55 minus 15 times 3. Distributing, we get 4 times 15 minus 1 times 55. Then we can replace 15 by 125 minus 55 times 2. Distribute to get 4 times 125 minus 9 times 55. Then we can replace 55 by 305 minus 125 times 2. Distribute to get 22 times 125 minus 9 times 305. And then we can replace 125 by 1040 minus 305 times 3. Distribute to get 22 times 1040 minus 75 times 305. Right, so 5, or the GCD of 305 and 1040, is equal to negative 75 times 305 plus 22 times 1040.